Let's say that I want the transformation that's going to rotate a vector by an angle of pi over 3. So I didn't say which direction this was going to rotate a vector, so let's figure it out. So I'm going to need to know sine and cosine for pi over 3. So really quickly, just quick trig review. If that's an equilateral triangle, then I'm calling all the sides 2, and that makes this angle pi over 3 or 60 degrees. And then if I cut it in half, that means the bottom side is 1, and Pythagorean theorem tells me the height is going to be square root of 3. So now I'm all set up with my triangle. So our rotation matrix that's going to rotate an angle of pi over 3, I can denote with a pi over 3 down here. And we're going to fill in our pieces. So cosine of pi over 3 is 1/2. And sine of pi over 3 is square root of 3 over 2. So I'll have a negative square root of 3 over 2 right there, and a square root of 3 over 2 down here. So when I said that I hadn't told us yet which direction this matrix was going to rotate a vector, but we can figure that out by thinking about what's going to happen with that linear transformation. So if I start with a vector that I know where it is, so in particular, I'm going to choose this vector that points, this time let's point along the x-axis. So if I call that the vector x, then that points 1 to the right, but it does not point up or down. So that's going to be my column vector 1, 0. So if I look at what our rotation matrix does to this vector, that means I'm taking our rotation matrix and multiplying it by that vector 1, 0. I've got a 2 by 2 times a 2 by 1. We've already worked out that those dimensions work. So 1/2 times 1 plus negative 3/2 times 0. So I'll get 1/2. And square root of 3 over 2 times 1 plus 1/2 times 0. So I've got square root of 3 over 2. So if I come up here to the graph and I go to sketch this, we can already tell that this has rotated the vector counterclockwise, because both of these values put me in the first quadrant. I've got a positive x value, positive y value. So we went from a vector that looked like that to a vector that looked like that. So our x rotated the vector counterclockwise by pi over 3. Now I made the claim that a rotation matrix would not change the length of the vector. Well, let's do a quick check on that. Our original vector, 1, 0, if I were to look at the length, I think we can probably see it's 1, but if I use the formula, then the length of x would be the square root of 1 squared plus 0 squared, or 1. So the question is our new vector, does it also have a length of 1? So if I take the square root of 1/2 squared plus the square root of 3 over 2 squared, I'm hoping that we get 1. Well, 1/2 squared, so that's 1/4. Square root of 3 squared is then a positive 3, and 2 squared is 4, so that's 3/4. So inside my square root, I have 4/4, also known as 1.